So find f if f double prime of x is this. And you're given that f of 0 is 4 and f of 1 is 1. So trying to go back to f from this second derivative. Okay, so how do we do this? F prime of x, the way we're doing it, let's go with, this is second derivative, let's go with f prime of x. See, the thing is that we don't have a velocity. We got two positions here. See, at 0 it's 4 and f of 1 is 1. We don't have a f prime of something is something. So, it's a problem. What are we gonna do then? Well, we definitely do have this. Would you say it a constant? F prime of a constant. Is it making it more complicated? So if we integrate, what will be the integral of this? Let's integrate it, at least for right now. What's the integral of this? That'll be what? X to the third. 4? 4x to the third, and this would be what? 3x squared minus 4x. Man, is there a better way to do this? This is not good. The setup is not good. It's too. It will be, and then plus f prime of c. Let's put it in the back. So if we evaluate this, it's just going to be a constant at the end. Because it's just going to be a constant. But anyways, we plug in x. We're just going to have 4x cubed plus 3x squared minus 4x minus some constant that's going to go in for every x. And then you're going to get some constant. It's going to be some constant, no? It's going to be some other constant. Plus f prime of c. So making it more complicated. X cubed, 4x cubed plus 3x squared minus 4x minus c plus f prime of c is equal to f prime of x. And then we do it again. Let's see, we do it again. F of x is equal to, we got two of them. So at 0 is 4, we use this one. Oh no, let's use this 0. Um, 2x of this integrate this plus minus plus the 4, I guess, put it over here. From 0 to x. So if you plug in x and then plug in 0, there's still going to be a plus this 4. Because if you plug in x is 0 here, 0, 0, 0, 0, 0, f of 0. What would be f of 0? F of 0, we don't know what would be f of 0. We got a problem. Because f of 0, because we don't even know what f is. Well, f of 0 is 4. Duh. Because it's right here. F of 0 is 4. So if we plug in f of 0, F of 0 is 4, no? So that would be, so hold on here a second, So you plug in x, we get this x to the 4th, x to the 3rd, minus 2x, minus 6x, and then minus f of 0, 0, 0, 0, f of 0 is 4 minus 8. If we do it this way, all right, let's see. No, because I did minus, yeah, is equal to f of x. And we find if we could use this f of 1 equal to 1 to find c, or we can just do 0. Again, f of 0, if we do f of 0, we're saying that f of, to find the constant, to find the c. Could we do f of 0 again? F of 0? F of 0. So this is gone, this is gone. Well, no, then this will be gone. We don't want to do that. We want to use f of 1. F of 1, if we do f of 1, that'll be 1, 1, minus 2, minus c. F of 1 is 1. This cancels out. Move the c over that way. And then move this over this way. Because this is positive, move that over that way. It'll be 9c equal to 9. So then go here. It'll be, the function would be f of x equals x to the 4th plus x to the 3rd minus 2x and this c is 9, so this is 9 minus 11x f of x and then f of x. How do we? Let me give you the answer, okay, to this one. So this is way more complicated. There's no step-by-step way of doing it. Let's see what the answer to this is. What would you do? If we're gonna do it this way, this is what the answer is. So this is the setup. This is the problem. Why would it be like this? If we're that f of 0, okay, we're using f of 0. It's some rate. This c value is still some rate. It's a velocity, but it's still a number. So it will still be a constant. You see, it could be what? I'm just making up a number, 30 miles per hour or something like that. It's still some number. So it's still a constant even though it's a rate. This c value is a rate. So if we treat it this way, that we're going to use that at 0. This definitely not this would be the position of it. But we don't know what exactly the rate is. So we're saying c is whatever that rate is. So we integrate. So the problem I had when I did it is that this c, I called it f prime of, what did I call it? F prime of c, wasn't it? That's what I had called it. But then this is also just a constant. That was the problem. Yes? That's the misunderstanding. So now here, let's go. So f prime of x, we integrate. So it just be a constant. And we do it again. Just put it in the back and we do it again. But this time we do know that at time equal to 0, what should be here? 4. The 4. So I made it way more complicated, and let's remember this, that is, it is just a constant at the end. The velocity would have been a constant. And you would have just treated it as a constant. Integrate that. And now you could you use this? It doesn't matter which one you use. It would be the same for either one, because you're already in this world of the position that you want to figure out what the constant in is, and you could use this or this. It doesn't matter. We could just use f of 0 to find what the c value is. The problem is finding the c value. And so if it is f of 0, well, f of 0 is 4, so this is equal to 4. So if you plug in 0, what's going to go away though? If you plug in 0, then the constant, you got to use this one. You got to use this one because then it goes away. So you got to use f of 1. So you're going to use f of 1. F of 1. So that would be 1 plus 1 minus 2 plus c plus 4 equals 1. So then cancels out. And so c is negative 3. So this is negative 3. That's what we need. That makes sense? We need to find that c value for that one. Just plug in the c is negative 3 and there's the function. The problem, and this is one of the more, the other one, if they would have given you this, f prime of 0 and that's f of 1, then it's easy. You just go step by step, just plug it in, continue and get it. But when they give you two that are positions and you want to get from a second derivative back to the original function, that's going to be a little more complicated. All right. Was there one like this on the homework?
Yeah.
There was? Did you solve it a different way?
I didn't know how to solve it.
It was, yeah. That's why I remember having this on the original lesson, like the original lesson for it, and I took it out of there and just put it here, but because it makes you think more. If I would have. Anyways, let's move on. Let's go antiderivatives. Let's go to the antiderivatives, lesson 6.8. What is an antiderivative? An antiderivative is an antiderivative. The antiderivative of function f is another function f whose derivative is f. Where it came from, when you took the derivative, it became the derivative, so where did it come from? Antiderivative. Example. If the derivative is f, what is antiderivative capital F? So if the derivative is 2x, what's its antiderivative? Integrated, which is what? X squared. So if we got some function, this is the derivative f, it's 2x, which is up 2 over 1, and it's a line. Its antiderivative was a quadratic, and it's going to be 2x. Basically, that's the idea we've been doing. So the integral, now here, this is a very important thing. The derivative is this. Okay, so here, let's go. So copy it down. Let's talk about this real quick. Whenever you took a derivative, say, okay, so we got x squared. You got x squared is the antiderivative. But it could have had a constant, and it could be infinite, whatever the number is. It could be 5. It could have been a 10. It could have been negative 100. So whenever you took the derivative of this, d dx, the derivative of this was what? What is the derivative of this? 2x. 2x. The derivative is 2x, which is this. But what did we lose? We lost the constant. So whenever we take the antiderivative and it's an indefinite integral, you have to add that constant when you integrate it. So when we go over here and we say the integral of it would be x squared plus c, because we lost that constant. So derivative and antiderivative. So the derivative is cosine x. What was its antiderivative? Well, it definitely has to be sine, isn't it? Something about sine. So the derivative, d dx, of sine x, what's the derivative of sine x? Cosine x? Is it? The derivative of sine, it is cosine x, no? So the antiderivative is sine x, no? The derivative of sine is cosine, isn't it?
Yeah. Oh.
And so you integrate cosine, you'll be, is it sine x or negative? It's negative?
Derivative of cosine x is negative.
The derivative of cosine is negative sine x. But let's see what it is. Let's see what we'll answer. When you integrate this cosine x, oh yes, it's sine x. It's just sine x. Okay, so the integral of cosine x is sine x plus c. The derivative of cosine is what? Negative, no? Negative sign. The derivative is 1x, 1 over x. The derivative is 1 over x. So what's this antiderivative? I mean, it's the plus c. These are called indefinite integrals because we got no upper or lower limits. We just want to find the antiderivatives of them. So what's the antiderivative of 1 over x? Ln x, so it'll be ln x plus c. This deals with the domain. This is just another thing. The domain is going to be absolute value of x because it's not on the left side of it. It's just the integral of 1 over x is just going to be on the right side. So it's just absolute value of x. Ln absolute value of x is the antiderivative of 1 over x. So the integral will be 1 over x. The integral of 1 over x is ln absolute value of x plus c. All right. So let's go over all these antiderivatives. We're all just going to go backwards of what we already know from derivatives. So the derivative of x to the n, this one is just like, there's no reason to even talk about it. You got some x to the sixth. What you do is you add a number to 6 and put that number at the bottom. And that's what we're going to do over there because this is the derivative of it. We know the derivative, and when we do the integral of it, you add a number to n to the power and then put that number at the bottom. And then don't forget the constant. No? Okay, as long as n does not equal to -1. Because if n is -1, that would make it 1 over x, which is the ln absolute value. Ln x. That's what we just did. The derivative of sine x, is what? Cosine x. So we want to integrate cosine x. And to integrate cosine x, we better get this back, no? So yeah, so the integral of cosine x dx is sine x plus c. The integral of cosine x, that one is going to be, the derivative of cosine x is what? That one's negative sine x. That when we say what is the integral of sine x, that one we're going to say what? Not just cosine, negative, it has to be negative. So the integral of sine x has to be negative. The integral of sine x dx is negative cosine x. Okay. Now you're gonna ask me which ones are essential to really just kind of memorize. And one thing I'm not good at memorizing things at all. So the derivative of tangent x. What's the derivative of tangent x? Yeah, it is. It is secant squared x. It is secant squared x. I think it is. Yeah, secant squared x. So now, when we integrate secant squared x dx, so the integral of secant squared x dx is what? What is it? What's the integral of secant squared? What's the integral of secant squared x dx? It's tangent x. It's just where it came from. So the integral of secant squared x dx is tangent x plus c. So yeah, they do competitions in like at MIT where they like, how much can you just remember? It's just like, who can memorize all these things? D dx e to the x. What's the derivative of e to the x? The same, e to the x. So the integral of e to the x dx, e to the x plus c, no? The derivative of b to the power of x, this is definitely essential right here. You need to know this. This one, what is it? Do you remember what it was? 2 to the x, the derivative of some exponential, d dx. It's gonna be, if I can remember it, is 2 to the x times ln of 2. That's what I remember it was. The derivative of 2 to the x will be, I think it's 2 to the x times ln 2, ln of base. So then if you do this, this would be what? Let's see. So the derivative of b to the x would be b to the x times ln b. All right. So if that's the derivative, the integral should be, instead of multiplying, dividing. So what's, well, integral of b to the x. Yeah, the integral. No, I'm doing this. I don't think I got this one quite right. Well, hold on here, yes. So the integral of something like this, the integral of say 2 to the x dx. So what would be the integral of 2 to the x dx? No, I just apply that to here. What's the integral of 2x divided by ln 2? Divide instead of multiply. What's the derivative of secant x? Secant tangent. So when you integrate secant x tangent x dx, it would be what? The integral of secant x tangent x? What's the integral of secant x tangent x? Secant x. D plus c. What's the derivative of tangent inverse of x? X squared, if you remember that one.
1 over 1 plus x squared.
Yes, it's 1 over 1 plus x squared, or 1 over x squared plus 1. So the integral of 1 over, this is Okay, absolutely important. You will definitely see a problem like this on the AP test. I'm pretty sure. Just they love this. So the integral of 1 over 1 plus x squared dx would be tangent inverse of x plus c. Maybe. Definitely. And this is a maybe. What's the derivative of this? Wasn't it square root? 1 over some square root of, wasn't it? So it's going to be 1 over square root of, is it 1 plus x squared or is it 1 minus x squared? Is it? Is it plus or minus? Quick. What do you think? 1 over square root of 1 minus x squared? I don't know. Let's see. Sine is minus. Sine is minus 1 over square root of 1 minus x squared. So the integral of 1 over 1 square root of 1 minus x squared dx is going to be sine inverse of x. Plus c. So which one is this one going to be? The derivative of cosine inverse of x. What's the derivative of cosine inverse of x?
1 over square root of 1 plus x squared.
Is it or is it the same but a negative in front of it? Let's see. Yeah, it's in front is a negative. In front of it is a negative. It's the same. 1 over square root of 1 minus x squared, but a negative in front of it. So the integral of negative 1 over square root of 1 minus x squared dx is cosine inverse of x. Plus c. All right. You don't need to be writing this down. Okay. Let's go. Yeah, I was going to do this. Jacob, integral of sine x dx. Did, huh? Negative cosine x. Vivian, integral cosine x dx. Anthony, integral 1 over x dx. Absolute value of x. Can't remember names. I know everything was. What's your name? Crystal. Crystal. Integral bx dx. I hope you remember that one. That's a tough one. Huh? E to the power x. Sean. Integral of secant squared x dx. Tangent x. To your integral secant x tangent x dx. Integral bx dx. Jacob. Bx dx will be bx over lnb. Vivian.
ln absolute value secant x.
Oh, secant x dx. What? ln? I don't even know that. I guess I don't remember that, but he's gonna remember that. Tangent x dx. Integral tangent x dx. Anybody?
Negative cosecant.
Is it negative cosecant x? Is it? Did we do that one? No. No, we didn't do that one, huh? Integral of tangent x dx?
Or it might be LBC.
I think it's L at secant, absolute value of secant x. I think. Cosecant x dx? Anybody? Cosecant x dx? Which one is it for integral of cosecant x dx? Huh? ln? The ln one? Cotangent x dx? So here, yeah, like I don't know them. I don't remember them. And you're like, which ones do you absolutely need to know? Well, I don't know. Definitely you need to know this for sure. You need to know this for sure, for sure, for sure. Maybes, 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 and maybes, all these. All right? So these are for sure. Okay, let's do some problems now then. Okay, so how can we do this? See, now if you're strong at algebra, then you can like manipulate this a little bit. Just multiply it in. So that would be square root of x. You need to quickly know the square root of x, fractional exponent 1/2, x to the 1/2. Square root of x is x to the 1/2, and then you're gonna multiply it times x. And so powers are added. So what is that? 3/2. So you need to be able to do this quickly. X to the 3/2 plus 4 times x to the 1/2 dx. And then you can use the first one that we went over of adding 1 to it. So this would be, and then put it at the bottom. So this would be x to the plus 2/2, which is what? 5/2, isn't it? Yes? Then divided by 5/2. Okay? 5/2. When we divide by half, the 2 goes to the top. So it's going to be 2/5. 2/5 x to the 5/2. And this is going to be plus what? 2/2 for this one. So it would be plus x to the 3/2, and then 3/2. So you got 4. I'll do it on the side. Divided by 3/2. So that 2 goes to the top. So 8/3. So this should be 8/3. And don't forget the plus c. Number 2, how would you integrate this? How do we integrate this? Anybody, any idea what to do? Just divide x squared into that and then into that. Let's so be, or separate them. Yeah. See, look. This came from being like this. 1 over x squared plus x to the 6 over x squared. See, it came from this, because you got common denominator, so therefore put it under 1 plus x squared, that's what it is. So separate it like this. And once you separate like this, you got 1 over x squared, then you can rewrite this as x to the negative 2. Well, there's no that. And then you can do this rule again. You can do this rule. So, and then this one, what is this? What is this? X to the negative 2. Okay, and then this is going to be plus what? X to the power 4 and dx, and then you can just do the power rule. So you're going to add 1 to it. So that's going to be what? X to the negative 1? X to the negative 1, and then negative 1 at the bottom, negative 1, and then plus x to the 5th, divided by 5, or 1/5, and then plus c. You can just simplify this more, negative 1 over x, and then plus 1/5 x to the 5th plus c. Let's do one more for today, and that would be it. And we'll continue on Wednesday with it. Yeah, well. Yeah, one thing people do is that they try to, I've seen it, you guys do it, some of you guys. Don't do that. That's definitely not it. You have to multiply it out in terms of that you have x squared plus 1 times x squared plus 1. That's what we gotta do. So multiply it out, x to the 4th plus x squared plus 1. FOIL it. Then you're going to get x to the 4th plus 2x squared plus 1. And now you can integrate this. Let's see. How much more? 4. That's a lot. Okay, hold on. 7, 6. You get the idea pretty much. You gotta know some trig identities also. That's where it comes from. That you need to know identities. All right.